Yeah, hello everybody. Today we are going to talk about package managers in C++. My name is Mikhail Svetkin. I'm a senior software engineer at Remarkable. I have around C++. I've been working with C++ for the last 11 years. Most of my areas of interest have been embedded networking. I spent some time developing frameworks, libraries, and for some reason I've touched build systems. Probably shouldn't do that. Yep. So what exactly we are going to talk today is what is the package management in general in C++. I will try to introduce you a Vcpkg and a Conan version 1. There is version 2 in beta, but I decided don't touch it. And then we will try to summarize that, compare the Vcpkg Conan and decide is it good to use them or not. And I'm sorry I'm starting to lose in my voice. Yeah. So let's start. What is the package management in C++? I tried to find a good definition for it, but I failed. So I took some definitions from the general package management. So it's fair to say it's a tool or collection of tools which simplifies to search, install, configure, upgrade, and remove your libraries. We can call it dependency as well. It can also supply you with a different kind of artifacts because some libraries, some projects need some special tools to be able to build and project. And if you've been on such talks before, where people talk about package management or dependency management, it usually talks about the same. And if you're wondering why I don't call this talk dependency manager or something else, I think this is the best answer. If you go to the Vcpkg main page, you will see that it calls himself a dependency manager, and the one line above it will call himself a package manager. The same applies for the Conan. It's called himself package manager, and later in the documentation it will call himself dependency and package manager. So I think it's not really important in terms here. I think in this talk it's the same. So to be able to understand what kind of issue dependency manager or package manager solve, I suggest you to write a small application with me. So let's imagine that we want to write an application which read the text file, process it, and print the output to stdout. So this is our small C++ application. And right now we have only one dependency is to the standard library, because most of the stuff we can do with the standard library as reading files and print to the stdout. And right now we have only one dependency. Everybody can take our project, can compile it, and there is no any issues because most of the compiler ships with the standard library. But let's say that we want to a little bit complicate our application. Let's say we want to add the support for the JSON library. And the way how we're usually going to do that, it's we need to look in the standard library. Is there any mentions of the JSON there? And you will find out that there is nothing there. So what next you're going to do, you probably go to the Google, you will Google C++ JSON library and find like 10, 15, 20 of them. So let's say in my example, I took the JSON spirit as a library, which I used to read the JSON file. And now we introduce a second dependency to our project. And if we want to tell somebody to build our project or use our project, they need to build JSON spirit before our library, before our application. And if somebody started to do that, they will realize that you don't only need to build the JSON spirit library, you also need to build some boost libraries because JSON spirit depends on the boost libraries. And I didn't specify which one because there is quite a few of them, I think 6 in total. So right now our project started to have 8 dependencies. Okay, good. Let's say that we want to a little bit more complicate our application. Let's say that we want to do some network communication. We don't just want to process the data from the file, but also want to send it to the server. So what we're going to do, again, we will look in the standard library. Is there anything mentioned about the networking in the standard library? And we'll find that there is nothing there. So we again will go to the Google or any other search engine which you prefer. And let's say that I found gRPC. And I said, yeah, let's use gRPC in our application. So now we have one more dependency. And now again, if we want to build our application, we first need to build gRPC, we need boost, we need JSON spirit, and only then we can build our application. When you try to build gRPC, it turns out you need quite a few other dependencies as well. And I didn't actually put the entire dependency graph here, just for this purpose. And let's assume this is all dependencies here. Yeah. Okay, now we have more dependencies, and each of them should be built in the right order, with the right flags and so on. But let's imagine that we somehow handle it, and I'm only one developer right now, so it's fine for me. Then I decided make my application is a little bit more fancy. I decided let's add some graphical user interface. Every application is better if it has a graphical user interface. And I'm not going to look into standard library. Of course, it doesn't have anything about UI. Okay, so I just took the Qt here. And I'm not going to show how many Qt dependencies has because it has quite a lot and they depend platform dependent, so just say X platform deps. So now, if I decided to invite any of you to my project and say, hey, can you help me to build this feature or something? First question which you will ask probably is how to build it up. Because quite a few things I didn't show. What kind of version of the libraries I want to use. Like I didn't mention which version of Qt, which version of Boost, what kind of standard library I'm using. Yes, so you might try on your laptop to build it or a power station, and it fails. Because, well, maybe the library is different, version is different, maybe something else. Also, what I didn't mention here is that there is some dependencies. Some libraries can depend on the same packages. For example, OpenSSL. gRPC depends on it, and Qt depends on it. How do we sure that they both can use the same version of OpenSSL, and then that's fine? Yes. So there's so many issues with that. And if I invite 5 more developers into the project, and each of them, let's imagine, use Mac, Windows, Linux, Ubuntu, like CentOS, Gentoo, wherever, you know, and each of them will have their own issues to build it because it's just hard, yes? So how we're going to solve that problem? How I'm going to explain all of you how to build my project? One of the way to do it, and I've seen that in many companies which I used to work, is that we can write a wiki page. I hope you can read. Not the point. It's actually a cut from the how to build Qt 5 from source. The entire wiki page is quite bigger, but you see the point, and it has like CentOS, Mint, and other Linuxes. And the problem with the wiki pages is, first of all, they go out of date. And usually the ways how to maintain them is that the new employee came to the work, he tried to follow the guide, he fails, he tried to update it, or you get the new hardware, you try to do it from scratch, and again you fail. So you update it. That's nice. There is constant work. We can update it. But the question is there a different one is how we enforce the same version across the developers. Because you may test it with Qt version 5.2 or 5.6, but in the end we ship 5.12. So we all develop on the different versions, and at the end we ship something else. So the behavior could be different because different versions, yes? So what we can do differently, how we can solve that problem by not using the wiki page, which is always out of date. So the another solution which I saw is to use dependencies as subdirectories. You just take all the dependencies, create the third-party folder, and put everything there, which is probably a solution. And the problem is that if you have a couple of the projects which have the same dependencies, then each project has a copy of these dependencies. So basically, you have to recompile them each time when you do a clean build or just clone the project. This source cost of these dependencies takes some disk space, not that big, but still. It's also hard to test against the different versions of the dependencies. Like if I want to test, okay, I tested my dependency right now, Qt 5.10 or Boost some version, but I want to test it against something else. Yes, how do I do that? Do I do git checkout or wherever? Yes, it's hard. And then also, if I try to compile all the time with the different versions, I will find out that some libraries are quite heavy when you compile them. The object binary is quite big, so it sometimes can eat your disk space. Yes. And last one point which I want to add on purpose here is that if you use the CMake as a build system and you use your third-party things as a subdirectory. You can do add subdirectory and it will kind of build. The problem is that the target names might collide because everybody tends to name things the same way. Like I have a core library, I have a GUI library, I have some tools, yes? And they may collide. CMake kind of doesn't like it. And the reason why I put the CMake only because I want to put the next slide. This is a small developer survey made by ISO CPP. And if you see, I'm not sure if you can see, but CMake is the biggest build system, the most popular, and it grows every year. I know some of you may be disappointed about that. That's life. Let's just accept it, and I will explain why we should accept it a little bit later. Yeah. Okay, what else we can do? Some companies do another way. They build their own solution. They build their own build system, they build their own package manager, they build their own dependency manager, wherever they call it. And I'm not going to say anything bad about that. I just say you had your arguments to do that. Please do. Continue if it works for you. But I hope that maybe at the end of this talk we will try to think maybe we should delegate that to package manager. Yeah. So what else we can use? If somebody has any other opinions what to use, please say, because that's all solutions which I suggest, except to start to use package managers. And nowadays we have two biggest package managers. It's a Conan, which has almost 1,354 packages available. We have Vcpkg, which has 1,910 packages available. And if you think this is a big number for the languages which have been like for the last 40 years, so look at the cargo. It has 19,000 packages, surprisingly. And Python, for example, has 140,000. And Node.js has around 600,000 packages. I'm not saying it's good. Node.js has a problem that if you build a hello world, you need 10,000 packages to do that. So it's not like a good thing, but still. And only the reason why I'm showing the comparison here with the package count is because while I was preparing this talk, I found the interesting information that 4 years ago, Conan approximately had 340 packages. It's not confirmed because I couldn't find any other sources to say this is exactly the number. I could find that Vcpkg had 800 and the cargo had 1,800. So in 4 years, Rust gets so many packages as C++ could only dream about. And the question is why? Why is the cargo so good? Rust is maybe a better language, I don't know, but what's there? And I can answer why it's hard. I found the answer. Because we have so many different build systems. And if you want to make a package manager, you need to support all of them because some libraries use that package manager, some libraries use that one. And if you want to have a big amount of packages available, you need to support all of them. And it's hard. Some of them have different versions, some different flags, and you need to maintain it. It's just a lot of work. So that's why I'm saying use CMake. I know it's sometimes painful, but please do, or improve it. Yeah. Then we have a lot of different compilers, and they have different versions, they have different flags. It's good that GCC and Golang are very compatible in flags, but MSVC is completely out of there. And there is also some custom, like other vendors' compilers, which may be not compatible at all. So your build system should be designed, or a package manager should be designed in a way that you can customize the things. We also have a lot of different standard libraries. And that means package manager should be aware that building one library with another one standard library, it maybe doesn't work, so he needs to handle such things. Yes, we have different standard versions. It's not a big deal, but you still need to be aware of that to be able to pass these flags and try to build as it should be. We have a project preprocessor flags, which can change the way how things works. And we have platform-specific flags. So the C++ package managers, they're not only solving the issues as any other package managers, but they also have a lot of domain knowledge, specific needs which you need to think about it. And it's kind of hard. So what do we actually want from the C++ package manager? I would say that we want a simple integration because many people get used to do some things, and it would be nice if you have a company which has 400 developers, for example, and that you don't need to teach everybody that, okay, now you have to build differently. So it's good if it just works. It's ideal. It's hard to achieve, but maybe we will achieve it today. Then we want to download, configure, build, and reuse libraries. So we want to delegate this to the package manager. We don't want to deal with that at all. It should support cross-compilation because if it doesn't, then it doesn't make sense to use it all because I don't want to have all the laptops, all the machines to be around to be able to do anything. It should support custom registry, and what I mean here is that we all have our own private libraries. We don't want to share them because for many different reasons. So it should be able that this package manager should be able to work with our internal dependencies somehow. I would also say that it should configure the developer environment. It's more like wish in a way. It just like if you have ever worked with any other languages like Python or Node.js, you basically need a Node.js and then everything else will be installed for your PC. You don't need to do anything. Yes? And I would say I added last point only because when I start to work with Conan, I had some issues, so I will talk about it a bit later. But I would say ideally that the package manager shouldn't have any dependencies at all. By the way, how many of you are using any package managers right now? Okay, quite few. I hope that number will increase by the end of this talk. But let's see. Let's start with the Vcpkg. This is my favorite one. That's why it's first. So, sorry. So Vcpkg is a standalone. It's portable. It's open source, written in C++ by Microsoft, and it contains ports only. And ports means here it's just basically a recipe how to build the library for you. How do we get the Vcpkg? There is basically two ways. One is like the default one. You just clone the repository. It contains only recipes. It has small bootstrap script which will download the Vcpkg command line tool for you. And that's all. There is a second one which I found on Microsoft blog post about Vcpkg. If you trust to download and execute some scripts from network, please do that. I'm not, so don't recommend that one. Once you get the Vcpkg, you kind of enter to the command line mode, and this works as a normal Linux package manager or Mac Brew or Windows Chocolate, something like this. You just say search for my library, install the library. You can install different versions, kind of different build configurations. Here, like by default in Linux, it builds statically all the libraries. So if you want to build a dynamic library, you specify this configuration point, and if you want to like farm and so on. You can also look at the dependency graph, and you can rebuild. Basically, like normal package manager. Nothing fancy here. The only one thing is that you cannot do in command line is that you cannot specify which version of the FMT library. So it will be always by default the latest available in Vcpkg. To be able to solve that problem, how to specify the version for your particular project, Microsoft released like a half year ago or a year ago manifest mode. So it's basically you have a vcpkg.json file in the root of your project where you just say name, version, string, and your dependencies. You can again omit the versions if you want. Then again you will get the latest one. But if you want to be precise about the versions, you can do it like this. Syntax is a little bit weird, I would say, but it is how it is. Like here what we have is that if when we're going to fetch the gRPC, we will get at least version 1.48. And for FMT, we will precisely want to ask for 8.1. And this built-in baseline, this is basically a commit, hash of the commit of which in this Vcpkg repository go to and look for the package information. So that's the mechanism. Okay, now we imagine that we install the libraries, we have this vcpkg.json, or we use command line, it doesn't matter. The next important step is how to integrate it in your CMake project. And again, I'm going to talk about only CMake here. First of all, Vcpkg works almost only with CMake as an integration point. It supports Microsoft MC's build, but I've never tried that one, so just stick with CMake. So, and the integration is pretty simple. You just need to specify CMake toolchain file, nothing else. So the first time when you call the configuration step, it will, before running the configuration step, download all your dependency, build them, store them for you, just works. Then it will just normal CMake. Have anybody used CMake presets here? Okay, then I will skip the next slide. But I will just show this. If you have not used CMake presets, are you curious what it is? Just look at that. It's like a way to hide all your way how to configure build the project. You just specify the name and you have JSON file where you describe all the things. Very nice. Because in that way, you kind of doesn't even see that you integrated with Vcpkg, which is nice. So if you already get used to that, then it's like, well, yeah, Vcpkg, Conan, wherever, doesn't really matter. Okay. I mentioned in the command line mode that you can specify what kind of configurations of the library you want to use. And it's done through this triplets files. It looks like this. It's a CMake file, and as I said, Vcpkg is very CMake centric. Again, wait, sorry, this microphone doesn't work for me. Yeah, so it's a small configuration file where you say what kind of linkage you want, what is your operating system, maybe some custom operating system specific needs, like change the air path for Linux. You don't have it on Windows, so you don't need it. And the way how to integrate it with your CMake, you specify these special Vcpkg variables. If you use the presets, you again put it there and you don't care about this. There's a couple of options for CMake, like what is your target triplet, what is my host triplet, and yeah, nothing really fancy here. So okay, let's imagine that you took the Vcpkg, you tried to build and everything fine, then the question how to add the library which is not in the library list, because there was only 1,900 something packages. So to add the package is not that complicated, but some work. So first you need to fork the Microsoft, there's two options basically. One is to fork the Microsoft Vcpkg repository, add a new port, make sure that all your developers use your fork, or you can send a pull request back them. They are very good at reviewing them, and they have a CI pipeline so they can run and test that it works on some configurations. So yeah, they're very welcome to the new ports basically. Or you can create your custom registry. You can add a new port. You can add this magic file, vcpkg-configuration.json to your project, and Vcpkg will understand that I need to use it instead of the main one. So let's imagine that we want to add the OurFMT library, and we just want to make maybe some different configurations. But basically, this is how the adding the package looks like. This is a port file, which is again CMake. So basically what you say, take some source code from that repository, run the CMake configuration, run the CMake install, and some helpers tools. That's all. Most of the port files looks like this. There is some 3 dots here. I actually hide some information from you. There is like 50 lines how to install the copyright and some names of the libraries, but yeah, because we know we use CMake everybody differently. There is no one unified case how to use CMake. So there is, every port almost has this section where it's like, okay, for you, I need to install copyrights or license or something else different. So yeah, there is some hassle. Yeah, then you go to the Vcpkg configuration.json. You say that you have one more registry. You say that it's a kind of Git. It could be a file system. It could be some just storage remote. Then you say the address where to look for your registry. You say the baseline similar to the vcpkg.json, and then you say this registry provide me that library. So every time when you install a library, it will use your own library, like FMT in that case. And there is also one more experimental feature with the vcpkg.configuration dash configuration.json. It's called artifacts. So basically, this is an attempt to provide you some tools for your environment. And here is basically you are the second, like this is just a code snippet which I took from the Microsoft blog post. But what they're doing here is they say we have some kind of new registry, kind of artifact. This is a location. Basically, it's a zip file which contains all the build tools pre-built one. So you can like say, I need a Ninja, I need a CMake, and it will provide it for you. So basically, if you have a VC package and you have have a CMake, then it will then load all this stuff and use that once instead. But by default, Vcpkg already actually built CMake, it doesn't load CMake and Ninja for you. So I'm not sure why they did this example. Yeah. Great. I want to do small live demo just to show how it works. I'm not sure how it's going to work. Live demo, they are hard, but let's see. I need to press escape. No. Yeah. Okay. So here. Yep. Okay. Yeah. I will increase the. You can see. And I cannot see anything. Okay, let me go to my project. It's a very small project. It doesn't have anything fancy into it. Okay. Yeah, so what I have here is that I have a CMake, which requires that I need to have at least 3 packages, FMT, protobuf, gRPC. I tried to generate from the from the gRPC works the way that you have a proto file and it generates you some code. So I just tried to generate it, and then I just tried to link it to my two libraries. And as you can see, there is no mentions of the Vcpkg or Conan, and I will use that example to show you that like my CMake project is not aware where the dependency coming from. Yes. Let me just open my cheat sheet with the comments because I don't remember them quite well. Okay. And also one note that I wanted initially to show you how to install the VC package, how to build it, and so on. And it turns out that to build dependencies for this small tiny project, it takes around 8 minutes. So we're not going to spend time on that. So let me just show you. So I already have a VC package. I already have a Conan install. And I will just copy this command, which is basically tell me, okay, call it CMake, build it in the builds Vcpkg simple. Use this current folder as a source folder. You can find the Vcpkg CMake there. Manifest file is there. Probably should have shown you manifest first, but yeah, I already built it, so I will just remove the folder, and I will show you how the manifest looks like. Vcpkg simple. Yeah, that's how manifest looks like as I show you on the slides. So now when I execute this command, the first thing which you will see is that the Vcpkg. Wait. Okay. Yeah. Okay. The first thing which you will see is that this is the amount of dependencies which requires to be installed. And also, since I already built that project before, so all dependencies have been built before, so you'll see that here is called restored 11 packages. So actually not rebuilding them at all. Yes, and it just install it for me. And as a result, I get this. There is a folder called Vcpkg installed, and it has the name of the triplet in it, and all my libraries are there. I don't see what I typed. Okay. Wait. Yeah, sorry. But you get the point. All these libraries are here. So great. And as I said, if you really want to use something more nice than just this, you can use CMake presets. and in that way it will look like this. I already have a configuration for the presets. I just call it, and it just do the same things. Because again, I have the folder. Let me just drop the entire build folder. Yeah, it does the same thing. Nothing special, just different versions of how to integrate. Okay, let's try to go back to slides. Like, how can I do that? Okay, that's not what I want. 1 second. I will do it here first. Okay. Yeah, great. So this is the cache result. So when I don't have any packages built before, so that's the time which it takes 7 minutes, almost 8 actually minutes to build all the dependencies for that small tiny project. And the next time when I call it, it's only 3.4 seconds, which is pretty nice. Yeah, how this caching mechanism works is that Vcpkg calculate a hash per each package, and what they do is they basically collect a lot of information about your building environment, also collect what kind of triplet you use and kind of Vcpkg version you use, some tool chains, so many things here, which makes this hash unique and make sure that you are not able to use some package which is not compatible with you. Some people say that Vcpkg goes very conservative way because it has so many things which makes it a little bit hard to reuse. But that's part of their philosophy, that they said that it should be hard because we are not sure that you can just easily take the package and reuse it on any environment, in any environment. Yeah. The way how the Vcpkg caching works is that it builds dependencies. It can fetch it from the remote storage, but you need to set up it manually. So the way how this remote storage works, that it's either wrapped to the NuGet packages, or they call it cloud object storage. I'm not sure what they mean, but they mean that. And then they kind of, during the build, they build the package, wrap it to the, let's say, NuGet package, and upload to the storage. Next time when they build, they check if the hash match, they will fetch it from the build server. And the Vcpkg supports integration with any NuGet compatible instances. It supports GitHub packages, Azure artifacts, Azure Blob, Google Cloud. So basically, you can choose where you want to store your binaries. Okay, 1 second. Okay, let's think. Does the Vcpkg meet our needs? Integration is pretty simple for those who already use CMake. It shouldn't be a big issue at all. It supports binary caching, so it's either store everything locally, and I show you as an example that all packages has been restored effectively. It can support remote binary caching in case, for example, if you want to build Qt, you don't want to build Qt. But if you need to build Qt, if you want to be precise on the version, it takes time. Depends on how powerful your PC, but let's say it even takes 20 minutes. And you don't want to wait this 20 minutes. Yes, you probably want to pre-build it, store it somewhere, and then everybody else can fetch it and use it. So remote option is quite nice. And especially it's also useful for CI, because we know that we run CI all the time with everything from scratch, but really dependencies are not that important in that case, from my opinion. Yeah, we also want a cross compilation. It works. It allows you to manage version, to be precise on the version. It supports custom registry. It can download the developer tools. Some parts are still experimental because it's a new thing, and it doesn't have any extra dependencies. So that's a quick intro to the Vcpkg, and I suggest to go to the Conan. Conan is the first thing I've ever tried, and I was so happy until I discovered Vcpkg. So I will try to be encouraging to use Conan because I'm on the Vcpkg side, but yeah, feel free to say that I don't understand Conan. Yeah, so Conan is a portable, it's open source, written in Python, it's by JFrog and contains recipes only. Recipes ports is the same, there is no big difference in my opinion. How to get the Conan is that you need to use the recommended way. Pip install Conan and also use virtual environment. It would be Very nice. The way I highlighted this is a recommended way because I did it wrongly. I use Arch Linux and I have a package called Conan, so I install it. And when I was preparing the demo, I basically run it one day, it works, and then I upgraded the system Python version, and then it didn't work for some reason. So it turns out that if I update the Python system version, I need to update all the Python packages, and I was like, okay, I don't do that. So this is a recommended way, please follow this one. You can also visit their website, they have some installers, I'm not sure how safe they are, but yeah, choose the best option for you. Yeah. Once you get the Conan, you need to set up it. It's the first difference between the Vcpkg, because Vcpkg we get it, we just use it. Conan you have to set up. Conan has this concept of profiles. It's similar to triplets, but it's more like global one. You can share them and they can include each other. But basically, the profiles looks like this. It has some settings, notes about what kind of operating system, what kind of compiler you use, what the build type. And the first thing which every guide for Conan 1 has is that you need to change what kind of standard library you're going to use, because for the binary backward compatibility they use the old one, so you want to change it. From Conan 2.0 it will be by default C++11. Yeah, then you also can specify some options. For example, you know that you're going to build some libraries, so I want this profile to build this library, all this is shared. You can also require some tools if you need, and you also can pass some environment variables like which compiler exactly we want to take and so on, and maybe some other things. So when you set up it, when everything is done, you can start to use command line mode. And the command line mode is a little bit different again with Vcpkg. Since Vcpkg has this global way of doing things, Conan you can search the library, it can show the information, but it cannot install globally. It always works with a project. There is another command called Conan download, but it's still not the same. Yes, and the Conan has these two files. One of them is TXT, one of them in Python, and it's basically like manifests, but one of them is in Python, the second one in text file. And we will start with the text file. This is a very simple Conan file, which looks like that, and we basically say what we want. We always need to specify the version. This is kind of a Conan way of doing things. You always have to be precise on the version. If you don't specify it, will complain. You can also specify this field. You actually have to specify this generators field. And because Conan is written in Python and their philosophy is like we're not CMake centric at all, you can choose what kind of build system you want to support. So this is example how to support CMake. They support different build systems, but they also have extension point to support your own build system. For those who has their own solutions, maybe it's time to integrate with a Conan. This is your chance. Maybe you will like it. Okay, this is a very simple file, but the full version of it looks like this. So what changed here is that first one was we want a FMT version 9. Here we get a different version. We can now specify for the gRPC that we want at least 1.47. We also said that we need 7-zip tool for some reason. We also can specify options, and we can say what to do when we build, when we're done. For example, on Windows it's quite useful. If you build some project and you have shared libraries, you have to place them together with your executable files, otherwise you cannot find them. So it's pretty nice that you can do that here. Okay, you get the Conan, you get this your TXT file, for example, and now you want to integrate it in your project. And this is again the difference between Vcpkg and Conan here, is that Conan is about like I want to support every build system which I want. So you have this tiny little step before call your CMake in general. You need to say Conan install and point to the manifest file, and it will go then load everything, generate CMake files necessary. In this case it's CMake Conan toolchain.cmake, and it will also generate some other files where to look find libraries. And then you can normally call CMake, you can call build. And the integration is quite simple, but it has extra step. Not all IDEs support that extra step, so that could be something new to learn for sure. But you probably can wrap it around. I know that some people has some CMake magic to call Conan first, so it kind of helps. Second one is a Conan file.py, and this is exactly the same as this one. If you look at this, almost the same, but it's just basically in Python. You can write functions, you can build some other things. You can make if, what to do on Windows, what to do on Unix, what to do on that type of Linux distro, and so on. So it's more flexible. It gives you a lot of controls, but it's it's Python. I think my take probably here is that if you allow somebody write in a Python something for the build system, then maybe it becomes super complex. And if you look some packages, how they look like, it's like 300 of lines to build the FMT, for example. It's hard, I would say. So I would stick with that one. This is safe. This is also, but be sure when you use it, be careful. But many people maybe disagree with me about that. Yeah, and then when you have this Conan file.py, you can also build with it. And you also get some extra options, like for example, Conan file is also important. I forget to mention that if you want to build a package and you want to ship it to the to Conan's storage, for example, then you have to have this Conan file, as far as I understand, because it has some extra steps on how to create the package, how to basically make it. But correct me if I'm wrong. Yeah. Yes. So basically, it's the same, and you with the Conan file.py you get some extra commands, but generally it looks the same. It's actually one good point here is that if you work with different build systems on different platforms, then this is a way how to forget about them. Just use the Conan. So that is kind of a good thing. Or just use CMake everywhere. Okay. Conan supports many different build systems. You see the list. It also has possibility to support your own build system. I've never tried that, so but they claim that works. So probably it works. Okay, this is a time for the demo, and let's see if I can do a demo. I think I will try to do it this time differently. Okay. Okay, so I have this. It's the same project, nothing changed. I didn't do anything in the background, I promise. And I will publish the source code, so it should work for everybody. Yeah, so I have this Conan file.py, which is basically says that I need FMT, gRPC, and yeah, build stuff. I also have a TXT file, which looks pretty simple, and I will try to build. And because I didn't put philosophy of the Conan turns out that these two files should be in the root, but I didn't put it in the root. So for some reason I have to use a big command to build. So I will just copy it. So what I do is here I'm creating a build folder, then I go into it, I call install, point it to the txt file of the Conan, then I call CMake. So you see it's a little bit more steps, and it should work. It doesn't. Okay, that's a problem of the live demo, yes. I probably will not try to understand what it, let me see, missing, yeah, that could happen. So, because Conan usually tries to prefetch pre-built binaries in the Conan center, and you see is that it says, well, your FMT hash is not what we have, so it's kind of missing. So what you need to do is, I will slightly tweak the install command. I will say, no, this one. See, yeah, I need to add that build slash equal missing. Okay, it cannot even do this. Maybe I missed something. 1 second. Yeah, now it works. now it's actually started to build the FMT library for me. And if I go back, I believe, and I remove this build folder. Okay, and if I copy paste this command again, now it should work out of the box. No, again it's building. I passed the build missing. So sometimes it might happen, and that was actually a good point that it happens during the live. Otherwise you wouldn't trust me. So that's exactly what happened, and I want to show you when you first time press say Conan install, it might happen that you're missing pre-built packages, and then you need to explicitly say build missing. So probably one of the good points is always pass this build missing, then it will build. And it takes almost 9.5 minutes to build. The next time it was pretty fast. But I could have, if I say that I want to actually upload my binaries to storage, which is built-in feature, then yeah, I wouldn't have this issue, but I didn't want to set up it. So, okay, and the Conan hash calculation is a bit easier. So what they do is they only calculate hash based on the values in the profile. It's allow them to reuse the packages more like basically they don't care if you have a Linux and you just see the same version, no extra options, it should work for you. It might doesn't, but it should. So you could have the issues, and as you saw, I have some of them. So yeah, as I said, Conan caching mechanism work like that. First of all, when you try to build it, try to prefetch. If it cannot, it will build. It also can optionally wrap in the Conan packages and upload them to the storage, and next time we use that. As of support for the storage, I think the only one option is this. Correct me if somebody knows better, because I think since they sell self-managed JFrog Artifactory, so you can just take it and use it. And I think everybody else just do that, actually. Yeah. So let's try to answer on our question. Does Conan meets our needs? I think it is, kind of. Integration is simple enough with some extra steps, but it depends on your team. As I said, if you have 400 developers and you need to everybody learn for that one step and they didn't get used to that, maybe it would be hard. But if you have a small team, maybe it's good. It's very depends on your culture inside. It has binary caching, local and remote. It has a global artifactory, so it's like there is a lot of pre-built packages there. If you're using more like common distros like Ubuntu, for example, it should work for you. It supports cross-compilation, it supports version managing, it has custom registries, can download DevTools. And there is extra dependency for Python. I told you what kind of issue I had with Python. So I don't think it's very important, but yeah, it might affect your experience. Okay, let's try to summarize. So I put this table to try to compare them, and maybe it looks like Vcpkg looks better, or maybe it looks like Conan. I didn't do it in any purpose, just try to express my feelings. So I would say that Vcpkg is very simple to use because it looks like yet another package manager. So if you ever use package manager, it should be pretty easy. Conan is also works perfectly, but as I said, it depends. Like if everybody use some IDE like Qt Creator, for example, then building could be difficult because you have this extra step, and you need to set up it properly. So it might doesn't work very well at the beginning. So there is some step here. But if you have some specialist, it probably will make it beautiful. So that's why I say it depends. Yeah, this package simple integrate with CMake. It's perfectly fine. Conan integrates, yes. It depends on the build system, so I haven't tried all of them. But for CMake it was okay. Okay. Binary caching, Vcpkg has a local one, and it requires to set up remote if you want to do something. Conan has everything out of box, so it's good. It's definitely a point for the Conan. Both support cross-compilation, custom registry, cannot load DevTools. Vcpkg can do that, but it's some part experimental. So I would say Conan is more mature in that case. So it's also good. And this extra dependencies are just my thing. Just was surprised that I couldn't build because I upgraded my Python. I'm still complaining about that. Yeah. Yeah, if we take a look some key points like integration between CMake, you have this extra little step. But I'm quite sure you can make a toolchain file which calls Conan inside, so it should be probably fine, but maybe some extra steps here needed. And I didn't point the CMake presets here as example, and that's because Conan right now doesn't have a very good integration with presets, but as far as I understand, it should be, and it will be, so just wait for that. So I have decided don't say anything here. If we look at the cache results, how fast they are, you will see that Vcpkg is a little bit faster. But the thing is that Vcpkg is always using Ninja to building. Even if you don't have it, it will then load it for you. Conan, in my case, used makefiles, so they are slower. I tried to say use Ninja somehow. All my attempts fails, but probably there is a way to do that. Just me failed to figure it out. Yeah, and yeah, the second time the Conan was faster. And the reason is because Vcpkg stores all the binaries locally in the archives, in the zip archives, so it takes time to unzip, especially if you have a big library like Qt, for example. And the Conan is just stored there, it doesn't pack them. So it takes more size, but in the way it's faster to do configuration stuff. I'm quite sure that Vcpkg will do that at some point the same. Maybe I will go and do a pull request for them because I think it's cool. It's like I don't want to wait for extra 30 seconds. It's a little bit annoying. Yeah. So what is my conclusion? I would say it's better to have a package manager than don't, because I mean they works. They're not great, but they works. It's always possible to improve. Vcpkg is simpler in my point of view, but it's also less mature and flexible in some parts. And I would say that Conan provides better control of the things, especially if you have a Python file, you can do wherever you want actually. And it has nice API for extensions. I would say choose one, which one works for you, and be happy. Yep. And some links which I used to prepare my talk. I think I would recommend definitely the first one if you're not into CMake. This is a very nice guide to how to write a modern CMake projects and use Conan. There was, remember I said about dependency management or package management. This is the case. There are two talks which call dependency manager, but they talk about Vcpkg and they talk about Conan, which is called themselves package manager. So it's just a question of terminology, I would say. Yeah, and there is a good talk about what is the dependency management in general. So not looking into details of the package managers, but more like from the C++ point of view. Yeah, and this is a good survey to show how popular Conan, how many packages they have, and there's two links for the annual C++ developer survey, which includes a lot of information, which I show you like CMake is the most popular thing. And the funny part is that in this survey you will find that, yes, CMake is the most popular, but this is like one of the most pain points. So popular but painful. Yeah, and also use the JetBrains. They have a nice statistics on who and what to use. So yeah, thank you, and questions? I think. I hope, is everybody heard the question or I need to repeat? Okay. So yes, I actually had the same experience, but the tools are now improved. So now actually, if you have your own dependency which you using consuming through the Conan or Vcpkg, you actually don't need to anymore publish it. You can say I want to use it from here. So you actually can specify where you want to use it. It improves the build. Yeah. Otherwise, you build it, you test it, you publish it, you try against your application, you fail. Okay, you go again and like this circle, that just go directly. Yeah. Hmm? Vcpkg I remember correctly, but Conan I don't remember correctly. We can look at the docs after that talk. Okay. Yeah. The question was, is the Vcpkg password ever reheard, or I need to repeat it for the online? Okay. So licenses is yes. Both of them could collect the licenses, and you can do it. I just recently did for work this thing. Yeah, it's Vcpkg definitely tried to install all the licenses in a special folder, and then you just grab them. It doesn't check if it's compatible for your requirements. You have to do it manually, but at least it's there. You can go through them. So maybe you can do some scripting around here. As for the vulnerabilities, I'm not sure actually, because basically it just gives you a version. We have that version, and you may trust which version it is or it's not. And they have CIs, all Vcpkg and Conan. They promise that they test it. They promise that it works, but I mean you have to try. Otherwise, yeah. Yep. Yeah, you know, it's basically you want to use a registry, and all of them provide it. So Conan has its own way, Vcpkg has its own way, and you can point where you want to get it and what you want to get it, which version you want to get. So yes, that works. Anything else? Yeah. I actually tested a week ago with Boost because I did this talk with I prepared it. That's why I just took the JSON spirit, because I wanted to check if it actually works. It compiles. I'm not sure. My examples was pretty simple, just to run and see if yeah, I don't have anything wrong. So at least it compiles. Yeah, yes, and that's why like if I go fastly here, that was here, and I pointed it was 2 becomes 8, 6 dependencies. That's actually package manager told me that I will download only 6 boost packages. So it seems like it doesn't download everything. But again, you have to specify all the dependencies. It should be specified in JSON spirit. Yes. Yes. I think the best answer was from Bill Hoffman, if I remember his name correctly, the owner, CEO of Kitware. He said, "Don't do that." And if you go to particular that thing, let me see. This first thing, it will in this CPP now. There was a talk from him, and Mateos actually reference to him, and there is a slide. Don't use fetch content. It's limited. Allow the package manager to do the job. So I think this is the best answer here. But if just go in details, fetch content is fetching content, but yes, but it doesn't do caching. Yes, and you have to rebuild all the time from the clean build. So it has it can do the stuff, but not the same as package manager. Adding the small Conan file.txt or Vcpkg.json will be do the same thing for you. So I think it's good. Yeah. Any more questions? No? Thank you.